indirect proof and inequalities in one triangle. Okay, so what we're going to be looking at is when you just have one triangle, you're going to compare the angle to the side, and they're going to have a relationship. Okay, there's also going to be a side-to-side relationship. And so here's what they are. All right, here's the first one. In one triangle, not comparing two, but with just in one triangle to itself, the larger angle, the larger angle is going to be opposite the longer side. That's the first relationship. So the larger angle is going to be opposite the longer side. Here's the second one. In one triangle, all by itself, the longer side is going to be opposite the larger angle. So that one's going to work both ways, kind of like the converse. All right, so example number one. We're going to look at just one triangle. We'll call this triangle FGH. And I'm going to give you some measurements. So, side FG over here is going to be 19.6 inches long. Side GH over here is going to be 17.2 inches long. And side FH is going to be 20.4 inches long. Okay, so we know the lengths of all three sides. What we're going to do is we're going to write the angles in order from smallest to largest. And it could say largest to smallest. So they could just pay attention to smallest to largest or largest to smallest. All right? Now, normally, in order to do that, we would need the measurements. We would need to know how many degrees this angle is, how many degrees this angle is, and how many degrees this angle is. But we don't know anything about the angle measurements, right? The only thing that we do know is the side measurements, okay? So we're going to use this piece of information right here that says that in a triangle, the largest angle is going to be opposite the longer side. Okay, so if we're going to go from smallest to largest, we're going to have three angles, right? So which of these three sides is the larger? Oh, sorry, we're going to use this one, second one. The longer side is going to be opposite the larger angle. So which one's the longest side? This one right here, the 20.4, is the largest. And so it is opposite the largest angle. So the largest angle is going to be which one? G. So I'm going to put that one on the third one. Angle G is going to be the largest, or largest. When you say longest. Okay? So if G is the largest, we're going to use this to get the smallest or shortest. So which of these two that are left is the shortest? 17.2, right? So what angle is opposite the 17.2? F. So angle F is going to be the smallest angle. That means which one's left in the middle? H. Okay. All right, there's example now number 1. Now let's go the other direction. So example number 2. Here's our triangle. We'll call it PQR. Let me give you some measurements. Angle P is 60 degrees. Thank you. Yeah. Angle P is 60 degrees. Angle Q is 72 degrees. And angle R is 48 degrees. Can you read those okay, or do I need to go over them? All my markers have been dying. So this time, we're going to write the sides in order from shortest to longest. So we need 3, right? So what do you want to get first? Do you want to get the shortest side, or do you want to get the longest side? Shortest. So we want to look for the what kind of angle? Shortest. The smallest angle. So which is the smallest angle? 40. The 48. So we want the side that's opposite that. What side is that? PQ. So you say PQ is the shortest. And then of the 2 angles that are left, which one's the next shortest? The 60. What side is opposite the 60? QR. And then for the last one, you just go for the one that's left. That would be PR. All right, I'm going to move this up. You'll see it in just a second. And we're going to talk about something called the triangle inequality theorem. The triangle inequality theorem. And the triangle inequality theorem has to do with the side relationships of a triangle. Okay? So within a triangle, your sides can only be certain measurements. For instance, example number 3. Can we make a triangle with the following sides? 2 inches, 4 inches, and 8 inches. Okay. Now, all of you probably don't have a ruler on you, but I do. Got my little special ruler. And so I'm going to start with this longest side right here. I'm going to start with an 8-inch, okay, which is almost all the way across my paper. Okay. So if you want to estimate one, you're going to go all the way across your paper like this. That's about 8 inches long. Because most pages are, what, 8.5 by 11? So 8 would be just a little less than most pieces of paper. Okay. Now we need 2 more sides. We need a 2-inch side and a 4-inch side. So from this end point over here, I'm going to draw 2 inches, right? So from here, I'm going to come up 2 inches. And there's a side of a triangle that's 2 inches. And then the last side should be 4 inches. So over here, I'm going to go to my 4-inch, but what's happening? Is it going to make it?
No.
No, not going to make it. Okay. So your third side, the third side, which we'll call the longest side, is always going to need to be less than the sum of the two other sides. So in this case, 2 plus 4 is only 6. So it should be greater than 8 in order for it to make a triangle. Okay? What if we try a triangle in example number 4 of 2 inches, 3 inches, and 5 inches? Is that one going to work?
Yeah.
Got some people who say yes, some people who say no. So I'm going to start with the longest side, which is 5 inches. So I'm going to draw from 0 over to 5 right here. Okay? 2 inches is to right here, and then 3 inches is to there. So here's 2 inches, here's 3 inches. The whole thing is 5 inches. Will that make a triangle? Well, you see how flat it is? It's basically just a line. The 2 inches and the 3 inches are right on top of the 5 inches. It does not make a triangle because 2 plus 3 equals 5, and it should be greater than 5. Can't be exactly equal to it. It has to be greater than 5. So example number 5, can we make a triangle out of 3 inches, 4 inches, and 5 inches? The answer to this one is yes. This will make a triangle because 3 plus 4 is what? 7. And 7 is greater than 5. Okay? So if I take my ruler and I draw a side of 5 inches, and then I go 3 inches up this way, and then I would have 4 inches this way, it would make a nice, it actually ends up making a right triangle. Okay, so basically you need the sum of the two smaller sides, or shorter, needs to be greater than the longest side. Otherwise, it's not going to make a triangle, even if it's exactly equal. Right? Like we saw on example 4, it was exactly equal and it made a flat triangle. So it was like not a triangle. All right. One more thing we need to talk about, and that is called the range of the sides. Hi. Thank you. Okay. Thank you. You know what? He's not here. Oh, wait. Is Noah here? Oh, sorry. Sorry, it's Caden that's out. Sorry. All right. So the range of the two sides, or the range of one side, is going to be when you take your two sides and you're going to add them and you're going to subtract them. You guys can add and subtract, right? Okay. Some people aren't sure. All right. So, example number 6. We've got two sides of a triangle. Let me move that way up. There we go. We're going to start with a 3-inch side and an 8-inch side. The question is, What is the range